Now, I want to connect this with weighted averages before we go on, because that was the reason why I did weighted averages first. I'm going to compute also the average final temperature. So final, because this is the interesting one. The average starting temperature is very boring. It's 0. The average final temperature is, individually the temperatures are different. And the answer here is it's the integral from 0 to 1 of T times pi y dy divided by the integral from 0 to 1 of pi y dy. So this is the total temperature weighted appropriately to the volume of water that's involved at that temperature divided by the total volume of water. And we computed these two numbers. The number in the numerator is what we called 40 pi. And the number in the denominator, actually, this is easier than what we did last time with shells. You can just look at this and see that it's the area under a triangle. It's pi over 2. And so the answer here is 80 degrees. This is the average temperature. Note that this is a weighted average. The weighting here is different according to the height. The weighting factor is pi times y. That's the weighting factor. And that's not surprising. When y is small, there's less volume down here up above. Those are more important volumes because there's more water up at the top of the cauldron than there is down at the bottom of the cauldron. If you compare this to the ordinary average, if you take the maximum temperature plus the minimum temperature divided by 2, that would be 100 plus 70 divided by 2, you would get 85 degrees. And that's bigger. Why? Because the cooler water is on top, and the actual average, the correct weighted average, is lower than this fake average, which is not the true average in this context. All right? So the weighting is that the thing is getting fatter near the top.